All right, here's the derivative of the inverse hyperbolic tangent. And like so many others, I'm going to do this using the fact that I already know how to take the derivative of the hyperbolic tangent. That's the hyperbolic secant squared of x. And I know that the derivative of the inverse function will, of course, be the derivative, no, the reciprocal of the derivative of this function with the other variable plugged in. So, right, it's just inverse functions. They all work the same way. Take the function over to the other side here. So, take the hyperbolic tangent of y. That would be equal to x, and then implicitly differentiate derivative of hyperbolic tangent y with respect to x is the derivative of x with respect to x. The right hand side is the easy one, right? And then take the derivative of the hyperbolic tangent of y. Well, if I did it with respect to y, it would just be hyperbolic secant squared of y, but I'm not doing it with respect to y, I'm doing it with respect to x, so chain rule says multiply by dy dx, then solve for dy dx. Pause right here to ponder a moment. The derivative of the hyperbolic tangent of x is the hyperbolic secant squared of x, and the derivative of the inverse hyperbolic tangent x is 1 over the hyperbolic secant squared of y, right? The derivative of this inverse function is the reciprocal of the derivative of that function with the other variable plugged in. Okay. This is, however, completely unsatisfactory answer because I didn't start implicitly. I want explicitly. I want my answer as a function of x. And so I've got to get this back to x's. Now, I'm going to use a hyperbolic trig identity that I don't think I've written down yet. The one that I know is I know that the hyperbolic cosine squared of y minus the hyperbolic sine squared of y is equal to 1. I want to turn that into something with secants and tangents. And so in particular, I'm going to divide everything in sight here by cosh squared y, and I'll divide that side by cosh squared y as well. So what I get is 1 minus sinh squared y divided by cosh squared y is going to be the hyperbolic tangent squared y. Hyperbolic tangent squared y. So 1 minus that is the hyperbolic secant squared. So the identity involving sine and cosine I can pretty quickly turn into an identity involving hyperbolic tangent secant, and that's what I want right here. The hyperbolic secant of squared of y, that's my denominator, is 1 minus the hyperbolic tangent squared of y, and I know that the hyperbolic tangent of y is x. So this looks like a 1 minus x squared is equal to the hyperbolic secant squared of y, and my denominator there just becomes a 1 minus secant squared. If you remember back to taking the derivative of the inverse the inverse tangent, the regular inverse tangent, the relationship here is 1 plus the tangent squared is the secant squared, and so we ended up with a plus 1 over 1 plus x squared there. Now it's a minus, and hence the minus sign. So anyway, the derivative of the inverse hyperbolic tangent of x is 1 over 1 minus x squared. There you go.